know this is not your job. I just sent you an email for some, this is for me to print in my next class. I know it's not your job, and I don't wanna make a habit of it, it's just, do what? Yeah, I've already sent you the email.
Yeah, I saw it, sorry, I'm trying to go the street, so I'm listening, sorry.
No, that's all right, so.
Did you say on the email how many minutes or?
Um. Oh man, sometimes I forget that my microphone's turned off, or that I don't have the right screen on, and so here I was talking for about 15 seconds, and then realized, wait, they can't see or hear me. What's going on? How are y'all, Lorenzo? Good. Hey, is Alex back yet? Hey, Alex, how are you feeling? Milk that for as long as you can. So, sorry, Mom and Dad. I can't take out the garbage. I'm not feeling so good. Sooner or later, your mom's gonna catch on and be like, "Go take out the garbage." Milk it for as long as you can. Just not in my class, okay? All right. Well, hope everybody had enjoyed their Monday off. I know I needed it. I don't really talk about what happens on my weekend very much, but I had a terrible weekend. Um, we had our first COVID vaccine on Friday, my wife and and I don't know what it is about my body, but I never get sick. Knock on wood, I never get sick, but I had the worst reaction to it. I had fever and chills for sweat for 24 plus hours. On top of that, you have a sick 2-year-old, and then a 1 month old that just wants to cry and eat and tell you that she's hungry at 2 o'clock in the morning whenever she wants. It's all beautiful, but not being sick. Anyways, so I just recovered. Sunday and Monday, I just recovered. I didn't do anything. So, one of the things I did do yesterday was I did get your quizzes graded, and those grades have been posted to Blackboard. You can. I'll make a email announcement or some sort of. I keep saying I'm gonna make videos, but it's just so much easier to just make announcements. I'll post a how to view your graded quiz on Blackboard. Y'all may already know how to do that. And you can see any comments that I made on your quiz. I'll also be posting the key to the quiz just as soon as I get the opportunity to. This week um, or today. My sole objective is to answer your questions over assignments 3 and 4. Assignment 3 deals with linear applications. Assignment 4 deals with complex numbers. So, thinking into Friday, Friday we will answer your questions over assignment 5, which is going to be quadratic equations. And we're also going to have a quiz on Friday. So this is one of our busy weeks, because we're basically covering 2 assignments, answering 2 questions for 2 assignments today. And what that means is that on Friday you're going to have a quiz that's going to cover material from assignment 2, rational equations, assignment 3, which is the linear applications, and assignment 4, which is complex numbers. So, I hope that you are prepared today with having looked at both assignments 3 and 4, and if you have any questions, my job here today is to address those questions. So, the floor is yours, so to speak. If you have questions over the homework that you want to ask, or if there's any other Blackboard quiz related questions, we can address all of those during our time together here this morning. So, the floor is yours.
Can you go over number 3 on assignment 3?
Number 3 on assignment 3. Sure. So, seeing that's a word problem, I'm not going to write down the whole entire word problem, but I will I'll put it up here. Let me read it into real quickly. Going into the final exam, score counts twice. Okay, so this is for assignment 3. We're looking at problem number 3. This is an average problem. So, when it comes to dealing with average problems, remember we have a way to find the average. You take the sum. You take your you take the sum over the total number, and that's going to give you your average. So, let's start filling this in. Now, before we fill this in, there's a big important note. Going into the final exam, the score counts twice. So, your final exam the score counts twice. So, for example, if your score was a 90, then that would mean you have a 90 plus another 90. If the score counts twice, that means when you go through and start finding your sum, you're not going to have the 90 just once, but you're going to have it twice. Now, for us, the final exam is going to be our unknown. And anytime that we have an unknown, we're going to use a variable. I like to use the variable x because it's the number that we use all the time. So going into the final exam, the score counts twice. So that's our unknown. So we have x plus x, that's our final exam, plus the score of a 75, plus the score of an 83, plus the score of a 78. Now, that's our sum. We're going to add up all of those numbers. Now, how many numbers are there? How many terms are there? What? 5. 1, 2, 3, 4, 5. Equals, now this is going to equal our average. What do we want our average to be? We want it to be at least an 80. So we're going to just put 80 right there. And now this becomes a linear equation that we got to solve for x. So I would do a couple of things. I would simplify my numerator, and at the same time I'm going to get rid of that 5 in my denominator by multiplying both sides by 5. So we get 2x plus, alright, 5 and 3 is 18, or 8, plus 8 is 16, carry the 1, 7, 7 is 14, 15 plus 8, 236. I hope that's right. Is that right? Those of y'all with the calculator? 75, 83, 78. 75 and 75 makes 150. So that's going to be plus the 3 there, 153 plus the 8. Yeah, that should be right. Plus the 86, 83. Yeah, 236. Equals 8 times 5 is 40, tack on the 0, 400. So can we solve this for x? Maybe we should subtract 236 on both sides. That's going to be a 164. Then we'll divide both sides by 2. And we get x is equal to 82. Does that make sense how to do this problem now? So the key phrase in here is, the final exam score counts twice. That's the key phrase. Counts twice. So be on the lookout for those little descriptions about what the final exam counts as, or what any exam counts as. Alright, what else can we look at?
Can we go over number 6?
Number 6. So, number 6, including a 5% sales tax and in charge is $252 per night. Find the ends nightly cost before tax is added. So, for problem number 6, when we look at this 252, think this is your total cost. Taxes included. So you stayed at this hotel for one night, you go down to check out, and the clerk tells you you owe us $252, and you say, well, what about taxes? And he said, taxes, and he says, the taxes are already added. They're already in there. So then you're gonna ask, well, how much did the room cost before taxes? So the question that we wanna know is, what was the cost before taxes? Before taxes, what was the cost of the room? This is our X, that's our unknown. So here's what we know. We know that when you go through and, let's say you're going through and buying a pair of jeans, that pair of jeans costs X amount of dollars. Now, we know that when you look at that price tag of $30 for that pair of jeans, and you go up to the register to check out, you're not going to pay $30, you're going to pay a tax, right? Well, that tax is an addition to that price tag, and in our case, the tax is 5%, so we're going to add to that 5%, or 0.05 times that price tag. So again, think about this as a pair of jeans. The pair of jeans costs X amount of dollars. There's going to be additional taxes to it. The taxes are found by taking a percentage of the price of the pair of jeans. So in the context of this problem, the hotel costs so much per night, but they add to it 5% taxes, so that's 5% of the cost per night, is going to equate to the $252. And that's the equation that we have to solve. So I set it up, the way I set it up like this is I create it like a word problem, like how you would think about shopping for a pair of jeans or a gallon of, well, milk doesn't cost any taxes, or if you're buying a video game. Video game costs this amount, there's an additional taxes, and this is your total cost. So what ends up happening is you have X plus 0.05X is equal to 252, which then means since the coefficient in front of this X is a 1, you get 1.05X is equal to 252, which then means in order to get X by itself, we want to divide, so we're going to take 252 and divide it by 1.05, and that's going to give me X. And this is why we use a calculator in this class. 252 divided by 1.05. Oh, did I? I'm getting not the right answer. Clear. 252 divided 1.05. Oh, what did I do? Oh, yeah, you gotta divide and not add, Mr. Clopton. You gotta divide. What'd y'all get for X? What'd you get?
240.
Good. And that is the cost of, nightly cost of the inn. So, this is, how many of y'all have gone out and bought your own pair of jeans or your own shirt or a video game? Have y'all done that before? With your own money? Alright. So, you've experienced this. This is what we do. This is what we encounter every day in our life. That video game that says it costs $40, you don't spend $40 on it, do you? You spend 40 plus some percentage, maybe $43 on it, $42 and some odd cents. This is what you experience every single day. So when this inn is going to advertise their prices, they're going to come and say, hey, stay at our inn for $240 a night. That beats the dude over there that's charging $245 a night. But are you going to spend $240 a night? No, you're not, because you're going to apply taxes to the problem. In this case, they apply 5% of that, so 5% of that $240 is going to be $12. They're going to add another $12 to your $240 to charge you now $252. So that's how you set up these problems. The price plus percentage of the price is going to equal your total cost. Price plus the percentage of the price is going to equal your total cost. All right, what else can we look at?
Can we go over 19 over the fourth assignment?
What problem was that?
19 on the third.
Slow it down.
Number 19 on the
Number 19 on assignment 3? Okay. Assignment 3. 7 over an x minus 5 plus 2 is equal to an x minus 2 over an x minus 5. So this is a rational equation. We want to solve this rational equation by multiplying the equation through by an LCD. And the nice thing about this particular equation is the LCD, we only have one type of denominator. There's two fractions here, but they both have the same denominator. The only denominator that we have to deal with here is the x minus 5. So what we're going to do is we're going to distribute that x minus 5 to every single term. So follow me as I go through this. Instead of writing that out 1, 2, 3 times, let's just go through and multiply. X minus 5 times this first term. The x minus 5 cancels out with the x minus 5. We're left with 7. Now this next term, there's no fraction. There's no denominator. So nothing's going to cancel out. So we're going to have 2 times the x minus 5 equals, when you multiply the LCD of x minus 5 times the third term, x minus 5 cancels out with x minus 5, leaving you with x minus 2. Does that make sense? Can we solve this now? Okay. Good. What was the hiccup? What was the problem? What was the confusion on problem number 19, just out of curiosity?
I was just trying to figure out if I got the LCD right or wrong.
Yeah. LCD, if you put x minus 5, you're right. The goal of the LCD is to make all the fractions go away. If your LCD isn't making the fractions go away, then you got the wrong LCD. But if your LCD is making the fractions go away, then you're on the right track. Okay. Anything else?
Number 21.
21. Alright, so, again, we have a rational equation. We want the fractions to go away, so that means we need an LCD. So I'm asking the question, what is the LCD of x, 4, and 12? Those are my three denominators. So let's start off with the numbers, 4 and 12. So when I say LCD, we're talking about the least common multiples. So if I start counting by 4s and I start counting by 12s, what's the smallest multiple of both 4 and 12? If I count by 4s, 4, 8, 12, 16, 20, blah, blah, blah. Then if I start counting by 12, I don't have to go very far, stop. The LCD of 4 and 12 is going to be 12. So if I'll just look at my numbers, that tells me what the LC is going to be. But then I also have to deal with this x. So again, your LCD has to contain, your LCD has to make the fraction go away. So since we have the x in our denominator, we have to declare that LCD is going to be not just 12, but 12x. So I'm going to take that 12x and we're going to multiply it to all three terms. So let's just think about this. 12x times 1 over x. The x up top cancels out with the x on bottom, leaving you with 12 times 1. Minus 12x divided by 4. 12 divided by 4 is 3. The x stays with you, so you have 3x times 1. Equals 12 divided by 12 is 1. The x doesn't go away because there's no x in our denominator, so you're just left with x times 1. Which then gives you 12 minus 3x equals x. Can we go through and solve that equation? Are y'all following with me when I'm skipping a step that I typically do when I do my work. And I'm skipping this step for sake of time, but are you following with me when I say, when I'm just circling that 12 right there and I'm drawing the arrows and I'm saying, well, what happens when you take 12 and multiply it by this term? What happens when you take 12 and multiply it by this term? What happens when you take 12 and multiply it by that term? Are y'all following with me? Okay, good. I don't want to be losing anybody. All right. What else can we look at?
Can I have, can we go over question 14 on assignment 4?
Sure. Question 14 on assignment 4. We have 8I over,
Can you switch screens, please?
oh, will do. So, the, I'm just going to make a note. Method. To divide by a complex number, multiply the top and bottom by the complex conjugate of the denominator. If you have a situation such as this, where we are dividing by a complex number, you're going to take and you're going to multiply the top and the bottom by the conjugate of the denominator. Now, conjugate, all it's doing is you're just going to change the sign, separate into two terms. So this becomes 4 plus 3i over 4 plus 3i. Now, we have to get on board with a couple of things here. One of them is this. This whole entire term is equal to 1. Anything over itself is 1. We're just multiplying through by 1. We're not changing the value of this at all. All we're doing is multiplying by 1. So, in the numerator, this 8i, you have to be thinking, put your thinking cap on. This 8i is going to distribute so that you have 8 times 4 is a 32i. Then 8 times 3 is going to be 24i squared. And then the denominator, we got to think about foiling. Now, some cool simplification is going to happen. If you know what you're doing, you can just skip right to simplification, but sometimes we just got to know what we're doing before we do that. So let's just see what happens. 4 times 4 is 16. 4 times 3i is going to be 12i. Negative 3i times 4 is a negative 12i. Negative 3i times a positive 3i is a negative 9i squared. So, when we go through and simplify, remember that I squared is equal to negative 1. That's one of the definitions of I. So this becomes 32i minus 24, because I squared is negative 1, so 24 times negative 1 is a negative 24. Then you get 16. Now here's something that happens. Positive 12i and negative 12i cancel out. They're gone. And negative 9i squared, because I squared is negative 1, that's just going to become a positive 9. And here's one thing that you can say. And you can almost skip this middle step as long as you know what this is doing. Take a look at this. 16 is equal to 4 squared. Where's that 4 coming from? It's coming from this right here. 9 is equal to 3 squared. Where's the 3 coming from? It's coming from this 3 right here. Every single time you take a complex number and multiply it by its conjugate, you're going to get this thing where, one, the two middle terms cancel out, and because you're multiplying by a conjugate, a negative sign and a positive sign, you end up with a negative here. But because I squared is also negative, a negative of a negative is going to be now positive, you always end up with whatever this term is squared plus whatever this coefficient is squared. So we now get, I'm going to write this as negative 24 plus 32i over 25. Now this is not your final answer, because your final answer always has to be of the format a plus bi, meaning we have to have a real number plus or minus the imaginary number. So what we're going to do is we're going to split the fraction. And before I move on, I'm going to ask myself, does this simplify? The answer is no. And this is our final answer. Now, does it make sense what I did to go from here to here, splitting the fraction? Does that make sense? Okay, good. To get to this point right here, we multiplied through by the conjugate. We started simplifying the numerator and denominator, keeping our thought process of I squared is equal to negative 1. Does it make sense how we went from this statement to this statement? Yes? Okay. Any other questions with this problem? Okay. What else can we look at?
Number 18.
18. Five times the square root of negative 16 plus 3 times the square root of negative 81. So, one of the things that we learned in the notes was that the square root of negative b is equal to I times the square root of b. So, essentially, to get rid of the negative inside the radical, we can just put I out in front, and that will take care of everything. The reasoning is because square root of negative b can be rewritten as the square root of negative 1 times b, which we can now split the radical. And one of the definitions of I was that I is equal to the square root of negative 1. And so that's how we derive at this. So, when I look at this problem, one thing that you can do just right off the bat is you can replace that negative inside the radical with an I out in front. Now we want to simplify even further. Can I take the square root of 16? Sure, square root of 16 is 4. Now this is multiplying, so I'll just put that in parentheses and put 4 right there. Can I take the square root of 81? Sure, that's just 9. And everything's being multiplied here, so now let's just multiply our numbers together. 5 and 4 make 20. Tack on your I. 3 and 9 make 27. Tack on your I. And now these are like terms. So 20 plus a 27 is going to be a 47i. Does that make sense? Thumbs up? There we go. What else can we look at?
$22.
22. So on this problem, we can start off by doing that. We brought the negative out and put an I out in front of the radical. Let's take a little side thought over here. How do we simplify the square root of 12? I'm asking you.
You can take out a 3 and a 4, and that 4 comes out as a 2.
Good. Good. Exactly like that. So the reason is we're looking for a perfect square that's a factor of 12 or that divides into 12, and the answer is 4. So rewrite 12 as 4 times 3 and do it exactly as you said. So this now becomes negative 6 minus, the way I'm going to write it is 2i squared to 3 all over 48. Now, remember that the answer format must be of the form a plus bi. Meaning you have to have a real number plus the imaginary number. So to get into this format of real plus imaginary, we got to split the fraction. So it now becomes negative 6 over 48 minus 2i squared root of 3 over 48. And now I'm going to go through and simplify those two fractions. All right. 6 goes into 48. 6 goes into 48 8 times, so this becomes the negative of 1/8 minus 2 goes into 48 24 times, so we're just going to write this as two ways. You could write it as, the answer format is probably going to be square root of 3 over 24i. Let's try to do a better box. Does that make sense? Cool.
29.
Say again, please.
29.
29. So this is ex almost exactly like the hotel problem that we did earlier. It's just now we're not dealing with taxes, but we're dealing with a price reduction. So I'm gonna set this up. Price minus discount is equal to your total cost, where discount is a percentage of the price. So let's start filling things in. After a 40% price reduction, you purchased a camcorder for $468. What was the camcorder's price before the reduction? So there's a few words. What was price before? Those was and before. They're telling me that $468 is what the cost is after the discount happens. So that's going to be the 468. So do we know what the price is? Yes or no? Do we know what the price is? No. So what do we do if we don't know something? We assign it a variable, right? So this variable, we'll just call it X minus, now the discount is a percentage of the price. Well, what percentage are we dealing with? We're dealing with 40%. 40% as a decimal number is 0.4 of means to multiply of the price. Well, again, price is going to be X. That's the equation that we got to solve. The price, X, minus 40% of the price. So the price minus your discount is equal to now the total cost. So combining our like terms, we get 1x minus 0.4x is a 0.6x is equal to 468, which means that x is equal to 468 divided by a 0.6. And this is why I let y'all do this from here on out, because I just don't want to, well, I do have a calculator, but I'm not going to use it. What is the answer?
$780.
$780 smackaroos dollars. Now, I know that if you maybe type this problem into Google or found some other text, they may do something different. They may set this up with a like a part over whole.
Your conference is
equal
scheduled to end in 2 minutes.
Your percentage over 100. They may do that. That may be what you're familiar with. I just don't do that. I like looking at it in terms of an equation, that we're transcribing from the original problem. Okay. Given that we only have 2 minutes left, I already know it's not gonna be enough time to start and finish a whole problem, so we're just going to leave it there. Remember that we're going to have, answers, where we're gonna spend time answering questions over assignment 5, which is quadratic equations, on Friday. And,